Hi everybody, welcome back to another edition of Snack Time Science. Today I have my daughter Veronica with me because she has her asynchronous day of learning, which means we get to do some fun experiments at home that hopefully you can also enjoy. Asynchronous, for those of you who are not familiar, we're located in Northern Virginia, so our kids are still going to school completely online, and on Mondays they don't have live instruction. So they have work to complete, but they do different things. So maybe that's what's happening in your town, maybe not. We'd love to know more. But our goal is always to provide additional resources for you to be able to use at home. So hopefully this is a fun exploration this week. This week we are diving in, and maybe you can tell from some of the clues on the table, to all things static electricity. So we're going to do some fun experiments today to show you a bit more of how that works. And then later on in the week, Veronica and Grace came together to make static electric butterflies and snakes. But we'll save that for Rosie Makes at the end of the week. Yeah? Okay, so in order to understand static electricity, we kind of have to roll back a little bit and go back to kind of the way that matter interacts all around us. So everything around us is made up of
molecules. Or
what's the other word?
Atoms.
Atoms, okay? And atoms carry in them 3 different particles. Do you know what they are?
Molecules, atoms, and particles.
No. So there's 3 particles inside of an atom. They're called protons, neutrons, and
electrons.
And electrons. And all 3 of those particles carry something that's called a charge, okay? And you sometimes hear the word charge in electricity, hence static electricity, but every piece of matter carries with it a charge. Now, nature usually likes for the world to be balanced, so our charges are usually neutral because the positive and the negative balance each other out and we all stay happy and wonderful. But occasionally, the balance of those charges goes off, right? It gets imbalanced, right? So you have an imbalanced charge. And the result of that can be, have you ever touched a door handle and it zapped you?
Well, I haven't touched a door handle and it's zapped me, but it's kind of like,
Have you had a spark connect to you when you touched metal before?
Yes, except it usually happens when I touch plastic, like when you're sliding down a slide.
Okay.
And it's really hot.
Yeah, okay, so that's a really good point, right? So it can happen when you touch metal, it can also happen when you touch plastic, but usually when you're creating a static electric charge, something that's a conductor and something that's an insulator are interacting. So if something's a conductor, right, metals, salt water, different things like that, it allows the free movement of electrons a bit more than something that's an insulator that holds on tighter to them. So what does that actually mean? Let's take a look. We're going to compare it with magnets. Okay, so if you've ever played with magnets before, they have a north pole and a south pole, right? 2 ends, right? Opposites attract and likes repel, meaning they push away from each other. Electrons and protons, you can see they've been labeled here, protons and electrons, interact the same way that those magnetic poles do. So if I have an electron and a proton, they'll, what do they do?
Be friends.
They'll be friends. They want to be together. They're attracted. But what happens if I have an electron and an electron?
They don't like each other.
Yeah, they repel, right? If you put in all the force, but what's the natural thing that happens with them?
Naturally, they'll just, it will be like a force field between them.
Okay, force field. They push apart, all right? And so that same thing happens, that's what's interacting in your atom. So usually your atom is happily balanced, right? There's the same number of electrons and the same number of protons and roughly the same number of neutrons, but they carry a neutral charge. So when you can rub them against something, so your foot against carpet or your body against the slide, right, when you're going down the slide, what you're able to do in things that are conductors is rub some of those electrons off, and then what do they want to do? What do electrons want to do with each other?
Well, if you had an electron and an electron, they push away.
They push away, but then what do they want to come back to?
They want to come back to
a proton. Yeah, they want to be attracted back to a proton so everything gets to be balanced again. And that's when you sometimes get that shock of a charge or your hair stands up. So take a look at it. So right here I have wool. Wool is really good for letting us pull the electrons off of our balloon. Okay, and so I'm going to rub some of those electrons off and create my positively charged balloon. And then if I pull it over to Veronica's head, it'll start to pick her hair up. I don't know if you guys can see that on the camera, but her hair is flying like crazy. take a look. It's all over the place. But it'll move with it, right? Because those electrons are trying to be attracted to the protons. It'll work until everything becomes balanced again, and then it will let go. So look at the way that can also be turned into a power. So take a look. Let's put these away for just a moment so we can take a look at the experiment. So here I have a plastic straw. Do you think a plastic straw is an insulator, or do you think it's a conductor?
I think plastic straw is an insulator.
It's an insulator, right? So we're gonna rub it against this wool and start to really work to get those electrons off of it. And now we're gonna do this magic trick, okay? Get your elbows off the table so it doesn't run through our back. Thank you. Otherwise it won't work. And are you ready? With the power of my charge, I am going to move the straw without touching it. Move it back. I'm going to move the straw without touching it. Why do you think that's happening?
Because you put the electric sweater, whatever you want to call it.
The electron, the sweater is nice and rough, so it allows me to move those electrons and those protons around. And then, oh, that I hit, that didn't count. That doesn't count, hold on. But if I charge up my hand, let's do it one more time. Let's really start to charge it up. All right, now here, come here, rub your hand onto the sweater, and you can do it too. All right, you ready?
Yeah.
Are you guys ready? Veronica's gonna move the straw with the power of static electricity. All right, B, pick your hands up. All right, we're gonna balance this here real quick. No, flat palm near the side. It's already wanting to move because of the... Push it back. Look on this side. Can you pull it back to you? Okay. Don't touch it. Just hold it still. Woo! Can you see it's moving toward her? Super easy to try at home. Grab yourself a plastic straw, balance it on something, and rub it through the wool so you can move those protons and electrons apart so that they want to come back together. Let's look at it one other way. And then we'll let you guys go and experiment. We'll bring it back to you on Friday. So here I have an aluminum can, right? Electrons easily move. They like to be attracted to things. I'm going to rub my balloon onto the wool sweater and really get it nice and charged up. And then with the power of the balloon, I am going to attract my thing. You try. Ready? You can watch the movement of it. Okay, grab it and then put it near, but don't touch, and start moving it away. Yep. If it could do it, it would stick right to it. We're going to be really, really quiet. Ready? Shh. Ready? Here, jump down and go in front of the camera. Go over in front of the table for me. And stand right in front of the camera with your head. Right there. Don't move the camera. Here, stand there. It's alive!
This is crazy.
So eventually it'll stop, right? But that's the power of static electricity. And you want to know an even cooler thing? Static electricity is also what creates lightning, all right? So still some confusion as to how it happens, but effectively you have this imbalance of charges that are happening in clouds, and when they come back together to spark, instead of that spark on your finger, you can wind up with literally a spark of electricity. And just like I can re-shock her with static, or you can re-shock your finger, it's the same thing, that static electricity can definitely hit the same point twice. It's being attracted to the particles that are available, positive and negative, right? So you got to remember, positive and negative charges attract, and negative and negative, or positive and positive charges repel. And that attraction is what can create that spark of static electricity. So we hope you have fun with doing these experiments at home. Grab an aluminum can, a straw, and a balloon, and one of those sweaters that are going to be pulled out for fall, and have fun with it. Experiment with it. See what you can do. See what you can get to stick. See what you can get to fly. And speaking of flying, come back and see us on Friday for another edition of Rosie Makes, where the girls are going to make butterfly wings fly and snakes dance. So join us in for that, and we can't wait to see you. And if you have any questions in the interim, drop them in the comments, and we'd love to know. And then don't forget to check out Wednesdays for Rosie Reads, and we'll see you soon. Thanks so much.
Although this man
We can
might do it.